Hello and welcome to this igus webinar. My name is Rich, your host from IHS Global Spec. I'd like to review just a few housekeeping items with you before we begin. Let's take a moment to familiarize ourselves with the operation of the user interface for today's webinar. Now, the large window with the heading igus presentation in the upper left, that's the primary window for today's webinar. You should be seeing the welcome slide there right now. Just to the right of that main presentation window, you'll see the speaker's bio window with background information on today's presenter, Matt Mallory. Now, just below that is a Q&A window, and at any time during the presentation, you can enter a question into the box in the lower section of that window and click Submit. Your question will then be placed in the queue for the speakers to address when we get to that Q&A session. Now, if you look to the bottom of your screen, you will see several buttons. The first three either minimize or restore the three windows we've already talked about. The others will allow you to share this webinar with colleagues, contact us, visit our website, access social media pages, and lastly, do a little troubleshooting like running the system test or consulting the FAQ document. Now, if you can't remember what a particular button does, just hover your mouse pointer over it and a tooltip will appear with a description of that button's function. And now to get this webinar started, here's Matt Mallory.
Hi, first off, I'd like to thank you for attending today's webinar. I like to start a lot of my presentations off with this statement about tribology, and basically that's the core competency that igus is focusing on when we create our motion plastics. So we study two mating surfaces and the wear and the frictional characteristics in that system, and basically try to develop materials that are enhanced plastics for bearings. A lot of you are used to using parts that require oil and maintenance. If you look at the study done by MIT, you'll see that if we can reduce the oil cost, if we can reduce the wear, we might be able to reduce the overall cost of systems and applications. So with that, I'd like to start today's webinar. The topic of today's webinar is sliding versus rolling. We're going to discuss how to correctly implement plastic linear plane bearings into applications where perhaps you're more familiar with designing recirculating ball bearings. This is a way to help you improve the lifetime of your equipment, reduce the cost, and eliminate the maintenance from your applications. So this presentation is technical in nature, but there are a couple of key takeaways I hope that you're able to gain from it. Number one, I hope you get an understanding of how composite plastic bearings are made as well as how they work, how they operate, and how they differ than recirculating ball bearings in many applications, how they can help you reduce the maintenance and downtime associated with lubrication or lubrication-related failures in the field, how you can properly implement them into your designs so they work right, as well as give you some ideas of different application examples so you have a better understanding of when and where to use plastic bearings. The first step in the process of the webinar today is to help you get a better understanding of exactly how composite plastic bearings work, how they're able to offer cost reductions through self-lubrications, and how what we call motion plastics or engineered plastics differ from more simpler commercial plastics available on the market. So at igus, we aren't necessarily inventing new plastics, but what we are doing is we're developing new plastic compounds that are specifically and specially formulated for bearing applications. Not only linear bearings, but we also make materials that are suitable for rotary and pivoting applications as well. But what we do is we start with base polymers. It could be a POM, it could be a PA base, and those base polymers are responsible for the main mechanical properties of the bearing itself. It gives the core strength carrying capability and the core temperature limits of the product. To that, we add a matrix of solid lubrication. Sometimes that takes the form of PTFE fillers. There are other types of sometimes silicone type lubricants we add to the bearing materials, and those are responsible for reducing friction in the application. We also added strengthening fibers and reinforcement compounds into the base material, which not only help the load carrying capability, but they also help the wear resistance of the parts as well. So this bearing itself is only one half of the equation in a bearing system. The other half of the equation is the shaft or the rail that the bearing is riding against. Some people refer to that as a counterface. There's a material transfer of the bearing material into the microfinish of the shaft. And in this slide you see a cutaway of an application. The yellow material in the center is meant to be the linear bearing material, the plain bearing material riding on a shaft. In this slide there's a small video showing how this material process takes place. And what's important to understand is once the transfer is made, it can't be washed away, which this is a core benefit of plastic parts, is that they work well in applications that might be submerged or submitted to washdown type environments. Now here's a pretty cool animation from igus showing a large bottling line, and in a lot of these bottling lines there's a caustic washdown that takes place. The important thing to understand in an application like this is if you were trying to use bearings that required wet lubrication, as soon as they were sprayed with the washdown, the bearing lubricants would be leached from the system, causing you'd have to maintain the whole line by administering a relubrication system. Plastic bearings don't require this and are really well suited for applications that have chemical washdown or submerged in water. Now that we've talked a little bit about how plastic bearings work, how they basically are self-lubricating plastics, there are a couple of explanations I'd like to give about the geometry of the parts themselves. A lot of people are used to seeing plastic bearings in a simple sleeve or flanged form, but plastic linear bearings might have features on the outer diameter too that can help anti-rotation in your application, as well as keep the parts mechanically fixed in the axial direction. So they have locking features on the outer diameter. Very important on the inner diameter of plastic bearings from igus especially are grooves. And these grooves serve two purposes. One is that they are dirt channels, so if you're in an application that's heavily contaminated by dirt, soil, or particles, they can act as a channel for that media. But maybe even more critically, they're able to reduce the amount of thermal expansion of the ID of the bearing towards the shaft. What that means is that we can produce parts geometry to a tighter tolerance, to a tighter clearance in the application than you could with a standard sleeve bearing, because a standard sleeve bearing as it swells would only have one way to go, and that's towards the shaft, which could cause a failure. So the grooves on the ID are really a critical feature of a thermoplastic bearing. So now I'm sure you're all very impressed with how we make plastic bearings and how plastic bearings work, but probably the most important parts of the presentation are coming up. This is a frictional comparison of a composite plastic we call iGlide J, which happens to be a linear bearing specialist for the igus line of motion plastics. How the friction characteristics are different than more simple plastics on the right, such as PEEK or POM. You'll see that iGlide J has better friction on case-hardened steel, which is probably the most common linear bearing shaft material, as well as anodized aluminum. So really the advances in the tribology really shine when compared to simple plastics, not only with friction, but also with wear. Here are the results of wear testing of iGlide J versus these generic materials on case-hardened steel and anodized aluminum. And you'll see that iGlide J has been developed as a motion plastic and does have better wear resistance on these common linear bearing shafts than the more generic materials. Should be noted, PEEK was similar on case-hardened steel. The one thing I like to comment to that point is iGlide J is already tooled in industry standard linear bearing sizes, and PEEK is an expensive customizable type of plastic solution. So now we've discussed how plastic bearings are made, how the technology works, how they compare to more simple plastics. Now it's very important for us to compare them to the most common linear bearing systems available, which are recirculating ball bearings. So we'll talk a little bit about the advantages and disadvantages of both. We'll talk about the limitations of plastic sliding parts, when to use them, maybe when not to. And we'll also talk about some of the design flexibility that they may offer you for future applications. Some of the important attributes to discuss and to compare and contrast plastic sliding bearings versus linear recirculating ball bearings, number one would be that there's a frictional difference between the two. Recirculating ball bearings have a friction of 0.01. Plastic sliding bearings might have a friction from 0.16 to 0.25. So there are frictional differences that we'll go over. Linear recirculating ball bearings always require wet lubricant. That might be grease or oil, and plastic bearings don't require that external lubrication since they are self-lubricating. Recirculating ball bearings are really ideal for high precision applications or applications that have high speeds in conjunction with high loads. They also offer advantages in highly cantilevered applications outside of what we call the 2-to-1 ratio, which we'll discuss later. Plastic bearings are better suited for positioning applications, pick and place. They're also, since they don't have that lubrication system like ball bearings, they work really well in dirty or very clean environments. They offer cost reductions. They're ideal for lightweight applications as well as short strokes. This slide highlights the main benefits of each part, which are in green, and the main problems with each part in red. So you see ball bearings, because of their low coefficient of friction, enable applications that are hand powered to be moved easier. They require smaller drive forces. They also enable higher cantilevered loads. Ball bearings are also low clearance. Since they use rolling technology instead of sliding technology, they can be made to smaller tolerances. So that really positions them well in environments like machine tools or things where you're doing machining or moving small parts into very small places. The clearance is very small. Also very well for fast applications with high loads. Some of the negatives is that they can be cost prohibitive for some applications. They have problems in vibrations. They do require constant maintenance and lubrication. They can be loud, and they must use hardened shafting. Plastic bearings are self-lubricating, so no oil ever needs to be introduced outside of the system. They are resistant to dirt because of that. They're also, since they're just due to the mechanical properties of plastics, they're very much better with high static loads, with vibration dampening, and they can also perform different types of motion profiles, such as linear and rotating at the same time. They're low weight, cost effective. They can also be used on soft shafts, which is very important in a lot of industries that are using stainless, where ball bearings require 440C hardened shafting, which can actually pit and corrode, whereas plastic parts can use 300 stainless series steel that's easier to machine and has much better corrosion resistance. They also offer some of the problems, however, with plastic parts is that they do have higher coefficients of friction than ball bearings, as well as higher clearances due to the fact that they're sliding instead of rolling. Because plastic bearings don't operate on the same point-to-point contact that ball bearings do, they reduce the surface pressure in any given application. That makes them better in high static load environments or applications with shock loads that might cause the balls to embed into the shaft and cause galling. Same with vibrations and edge loads. And also, ball bearings are not really well suited for high acceleration applications due to the inertia in the balls. A lot of times I'll visit accounts and I'll see shafts with shaft damage at both the beginning and the end of travel, and that's caused mainly due to high accelerations where the motor starts moving but the balls, due to inertia problems, start sliding first and then kind of catch up as it goes along. Same thing happens during the deceleration process, or when the motor reverses course, the balls are moving in the opposite direction of the bearing itself, damaging the shaft. Plastic plain bearings don't have that type of problems. There are no real limits to the acceleration profiles for plastic parts. Don't just take igus word for it about plastic bearings and how they can save and reduce maintenance costs. We like to talk about that a lot, but both of these studies and basically any study done on bearing systems will tell you that the number one problem with any bearing system is due to lubrication related failures, and that could be from The parts were not maintained correctly, the grease was not administered at the right time or improperly. There could have been an environmental problem where using the grease in dirt, say, caused an ingress of contaminants into the ball bearing, causing a failure. It could be related to any number of issues, but the number one cause of bearing failure in manufacturing is bearing lubrication related. Since composite linear plastic bearings don't require these external lubricants, there's not the main problem of lubrication related failure. They also don't require the ancillary equipment required to keep lubrication clean. So plastic bearings don't require any special seals or wipers to keep lubrication out or dust out of the system. They are self-cleaning. And if you look at this application photograph on the right, you'll see two composite linear bearing rails that are in a, basically it's a cutoff soft or particle board. You could see the portion of the travel where the bearings travel over is clean. That's because the bearings have self-wiping attributes. If you look at the end of the shaft where the bearings don't travel, you'll note that the contamination is stuck to it. So the important thing to take away here is that plastic bearings are self-cleaning. They won't have lubrication-related problems like linear ball bearings can. A sometimes overlooked benefit that plastic bearings offer versus recirculating ball bearings is their weight reduction when compared to metals. This is important for not only industries where you're trying to save weight, like in the automotive industry or aircraft interiors. It's also important in any application where maybe you have a gantry system and one linear bearing axis is moving on another. It's important to keep the weight down in any machine design of the movements. That reduces the inertia and the moments in the system. It reduces the stresses on the motors, on the pulleys, on anything else in the application. You can use plastic bearings to help you eliminate, to lower the weight of your designs as well. As well as weight reductions, plastic bearings also have some unique designs that enable you to lower the overall profile of the linear bearing system in an application. I like this slide a lot. It compares a traditional ball bearing system, a recirculating ball bearing shaft rail assembly, 3/4 inch size, to a very common igus style linear system, which is the same carrying capability between the two, but you'll see the profile is considerably less on the DryLin WK20 on the right as it is to the industry standard igus OJUI 1112 on the left. What's important about this is that through this new technology, a whole series of new geometry has been created to help you be eliminated from previous design constraints of industry standard parts. One way igus has come up to help you kind of free yourselves, for lack of a better word, from this existing technology, we've simplified into what we call our DryLin W Toolkit, which is basically a series of different types of modular rails and bearing assemblies, from single rails to double rails, that offer you complete flexibility in how you assemble parts to your system. So we have double rails, which eliminate the need for alignment, and we have single rails, which allow the flexibility for you to space the rails however far apart you are requiring them for your application. I also like to note that a lot of people are used to, again, thinking about plastic bearings as a simple sleeve or flange bearing, when in fact, just like linear actuators that ball bearing manufacturers provide, either a tooth belt axis or lead screw, even rack and pinion, and as well as systems that incorporate stepper motors fully assembled with encoders or brakes as required in your application. So it's not just a simple sleeve or flange bushing. They can take the form of a complete system like these as well. Here's a really short video showing the evolution of a single rail DryLin W system with different plate widths, different mounting options. You can use just the bearing runner blocks in themselves or tie them together with a plate as shown, as well as our double rail systems. And these basically eliminate the need for any rail alignment, which can be problematic in a lot of applications, getting the rails perfectly right. Also available as a lead screw actuated system with or without a motor. Or for higher speed applications, a lot of times a tooth belt is required. So DryLin W is also available in a tooth gear system. One thing about plastic bearings we talked about earlier was the clearance that's associated with them. Our engineers have come up with clever ways to reduce that clearance through what we call the DryLin turn to fit system. So DryLin W and a lot of plastic linear bearings are able and well suited to run on hard anodized aluminum extrusions. These profiles offer a lot of flexibility and a lot of customization. Usually plastic linear bearing manufacturers like us utilize specialized extrusion mills that are able to produce extrusions to about 1/5 of the standard commercial tolerance. But one really unique thing that enables a lot of designers a real lot of value is the fact that you're able to design profiles for linear plastic guides. You're able to incorporate other features of your machine, maybe helping you to reduce parts, maybe helping, maybe you want to see a change in geometry, or you're going to not support it fully, so you want to add a strengthening feature, something like that. Another benefit is the fact that you can also, through the injection molding process, create custom plastic parts to match those rails. All right, now I'd like to get into the proper ways to implement plastic bearings into your applications. There's a couple of key things that have to be observed when you're working with sliding bearings instead of rolling bearings, and we're going to go over those things right now. The first principle is called the 2-to-1 rule, which has to do with cantilever loads and drives. Then we'll look at the proper use of fixed and floating bearings. And then we'll look at some online tools that are available for designers to help them basically realize applications using these type of bearings. So we'll take a look at that right now. Perhaps the most critical rule to follow, the golden rule to follow when designing with plastic sliding bearings or any type of sliding bearings that doesn't use grease or lubricant, is what we call the 2-to-1 rule. And basically it states that any acting force on the system, either which is usually a drive force or a payload, it has to be within a distance of 2 times the bearing length on the rail that's closest to the drive side. On that drive side, we call that the fixed bearing side, and we call the further side the floating bearing side in an optimal system. So this is a really cool thing. We're going to take a deeper look at that now here in the next few slides. Here we have a 2-rail 4-bearing system in which the drive force is on the right-hand side of the system. The bearing set that's closest to the drive side we designate the fixed bearing side. These bearings guarantee the precision and actually define where the 2-to-1 ratio is measured from. The opposite set of bearings we call floating bearings. They actually are able to float towards the other rail. The only purpose of those bearings are to carry the load in the direction of gravity and support the moment loads. First, we're going to look at a system that's designed properly, that's working well. And you can see I have a single rail here, and I have 2 bearings that are spaced 100 millimeters apart, and I have a drive force that's located 150 millimeters away. That means there's a ratio of 1.5 to 1. So according to the 2-to-1 rule, everything's going to work okay. If we look at this system in greater detail and we take into consideration the moment caused by the lever arm, we'll see that 100 newtons of drive force is creating a friction force on the bearings, an axial load of 25 newtons. That means the system is going to move since the drive force is greater than the axial load on the bearings. So everything will work perfectly fine in this type of application. Next, we'll look at an application that binds. And this is a system where the ratio is extended at 2.5 to 1. As you notice, we have 100 millimeters between bearings on the rail, and the drive force is 250 millimeters away. So again, that's a 2.5 to 1 ratio. So notice we're pushing on it with a drive force of 100 newtons, and the friction force caused by this is actually 125 newtons. That means that the system will bind, that no matter what you try to do, no matter if you try to increase drive force, you will not overcome the friction force that's causing an axial load of 125 newtons, because the required drive force is higher than the actual drive force. So in this type of system, the system will bind, the application will not work. If the load is positioned this far outside of 2 to 1, a lot of times you'll get a chattering or binding effect, some people refer to as stiction. A source of many phone calls we get at igus from engineers with problems with our linear bearing systems tend to be a result of the improper use of fixed and floating bearings. Basically, in order to optimize the 2 to 1 rule and to reduce the drive force and the axial loads and the lever moments into the system, we create a system based on 2 rails, which the side closest to the drive force is the fixed side, and the side furthest is the floating side. The floating side is only there to carry load in the direction of gravity, so it's designed actually to float in the direction of the other rail. And you can see here in this quick little video, some systems we have a clearance of plus or minus 1 millimeter, some have less. We'll look at a few designs or how floating bearings are designed here in the next slide. Square-shaped or profile guides are the easiest one. We simply either remove the plastic glide pads from the sides or top, depending on the orientation of the application, or we mold the plastic parts narrower. This enables the part to still carry a load in the direction of gravity, but slide and float towards the other rail. This not only helps with misalignments, but like I said before, this also helps optimize the 2 to 1. In round shaft or round rail designs, we, in an adapter form, which would have the same dimensional sizing as the recirculating ball bearing, we actually reduce the outer diameter of the adapter itself and add a little crown feature, and this enables a plus or minus half a degree of angular misalignment forgiveness. And usually O-rings are provided, which help reduce any noise caused by the metal-on-metal contact of the adapter pivoting inside of housing.
The real critical thing about fixed and floating bearings and how they can improve your design is, number one, they optimize the 2 to 1 ratio, which in turn reduces the drive power that the system needs in order to move, which means you can also maybe move something by hand that was before you need a motor to move, or you may need to be able to undersize your motor as well. It minimizes the wear in the bearing since the lever is decreased. It also increases the max permissible velocity of the system, and overall, contrary to what you might think, floating bearings actually help to maintain a better precision and clearance in the overall system over its life. They also help to compensate for angular misalignments in the rails or shafts. Now, if we look at this application here, this is a fixed bearing arrangement, which again is not ideal. You'll see in here we have 2 rails, 4 bearings. The bearings on both sides are 200 millimeters apart. The furthest side is then actually 400 millimeters away from the drive point. In a fixed bearing system, when you don't define one side as floating, you have to take a worst case scenario and consider that the drive force may be, the 2 to 1 rule may be defined from the furthest away. So let's compare this to a fixed floating bearing system next.
Now let's look at the same exact application, but we're going to use floating bearings on the side that is furthest from the drive force. So you see, if we do that, we determine or define the system from the fixed bearing side, which is in fact the one closest to the drive force. So instead of being right on the border of the 2 to 1 rule, like the last slide showed, we're now actually at half of that ratio. We're only 100 millimeters from the drive side, which is 200 millimeters between bearings. So we're well within the 2 to 1 rule in this configuration. Now let's look at the results. Now this is the really cool part. I really like to show engineers when I'm visiting them who are skeptical about the use of floating bearings, really the benefit. Because a lot of people, and it's kind of common sense, you'd think that by introducing a set of bearings that has enhanced clearance that you're actually going to increase the clearance in the whole system, when in fact it's not really like that. That fixed bearing side will define the precision of the system. What will happen though is if you add a floating side, you have the ability to reduce your drive force. So if you see in the fixed system we had a 500 Newton drive, by adding a floating side we dropped that down 66% to 167 newtons. The wear is dramatically reduced as well. This is probably after 1,000 kilometers of use. We're able to calculate wear per kilometer or per mile. So you see the clearance of the system brand new They're identical, but after use, after travel, the wear is reduced by 51%. This is simply by using floating bearing correctly in an application with an offset drive force. This absolutely can help you really refine and optimize the use of plastic linear bearings. A question you might be asking yourself is, well, if I put my drive force directly centered in between the two bearings or rails, do I need to use a floating bearing? The answer is no, but you can still benefit from the fact that it's much more forgiving for angular or any misalignments between rails or shafts. Other applications that really benefit also from the use of different types of floating bearings could be applications where you're mounting to enclosures that aren't quite rigid or straight, like if you're mounting to sheet metal components or parts that have been welded together, or even like some aluminum extrusions that are not rigid, or plastic that can twist when you're mounting to it, mounting either the carriage or to it. So there are a lot of fixes that floating bearings can provide engineers. And ball bearings seem to work fine at first with misalignments, but what happens is because the friction is so low that you don't notice it, but after time you'll start to see galling in the shaft. So plastic bearings are really ideal for any type of severe misalignments as well. To help make it easier for engineers to specify plastic bearings to make sure they're going to work correctly in their application, igus offers an online expert system. We call it the DryLin Expert 2.0. You're able to choose the geometry that you'd like to use in your application. Then you're able basically to model it up in our software, and from that get a series of results. You get to understand better if the part's going to move smoothly. Again, understand and get an idea of the clearance or wear in the application, as well as get an idea of the drive force. So we'll take a look quickly into the system here now in 2 slides. The first step after you've chosen the correct geometry, or the geometry you'd like to try to model up, basically you pick the size, you pick the amount of rails, the amount of carriages, and the orientation of the part, either it's vertical, lateral, or upside down. Input the spacing between bearings, and then you're off to the next step. One really critical function of this software is the fact that you're able to you're able to tell the system where the center of gravity is for your application and where you intend on driving it in your application. It's going to measure those coordinates from a preset 0 point established in the software, and after you put in your load, acceleration, and your expected lifetime travel, you're able to take the next step. So this is a real clear way to see it on the modeling software itself. Alright, after all your data is input, it's time to check out the results. And as you can see here, it says on the top right, there's a series of OKs in green, basically showing that the running characteristics of this particular application are okay. It'll give you the wear in both Y and Z direction. In this case, it's after 5,000 miles. You can toggle back and forth between metric and imperial. You can change, again, that expected lifetime. If you only have an application that travels 1,000 miles or kilometers, you can see the wear in that as well. Very critical, you're also able to determine what the drive force required to move it is, as well as any safety factors that you might be trying to design around. Another important thing is that if the value of OK is not given for the running characteristics or for the load or for the wear, you can click the optimization tabs, and the robot will tell you basically the solution, or the things you might need to change in the application to get it to work correctly. So it's a very easy, user-friendly system to use. Also from here you can then you get the part numbers and request the CAD file downloads right off the internet. It's very easy to use. I'd like to take a few minutes just to show a couple of applications, or to talk about some of the application parameters that plastic bearings can really work well in. And number one is, just because they're dry running, the fact that there's no external lubricants makes them really ideal for running in dirty environments. We've kind of stated this a couple times in the webinar, but we get a lot of phone calls from customers who are using ball bearings. Maybe they're only lasting a month or 2 months, or sometimes even days, where the lubricants are being embedded with particulates and causing failure in the system. Plastic bearings don't have that problem because they're running dry. They work really well in dirty environments. They're able to wipe clean their shaft as they pull. They have dirt channels to enhance their performance, and they've really been a a lot of problems can be solved by using these type of technologies. We also have a lot of applications where customers are requiring really quiet performance, unlike rolling ball bearings. That metal on metal contact has can be quite loud. So plastic sliding parts, again, work really well for quiet applications, ideal for a lot of film and studio equipment. We do a lot in that type of industry, as well as common manufacturing machinery. Another that really relies on quiet operation are aircraft interiors and sometimes lab machinery as well. One core industry for igus motion plastics is definitely lab automation, fluid handling. A lot of different lab machinery rely on linear plastic sliding parts. Pipetters is another instance, another example. But the fact that there's no lubrication makes them really well suited for any type of use around scientific chemicals or science chemistry. There's no lubrication to leach into the samples or into the systems, and it keeps the immediate lab environment clean. Here's an application on a blood analyzer on the elevator mechanism that we replaced ball bearings primarily due to the fact that there was no need for oil. Not only did they use plastic bearings, but they also coupled that with aluminum shafting, which is again the best mating surface for plastic sliding parts. The upfront cost savings to the customer was $36,000 per year versus the price of bearings. So not only were they offering a technical advantage, there was a price advantage as well, which is what is igus's mission. And I'm sure many of you are familiar with 3D printing. It's probably the hottest new industry right now that a lot of people are. It's kind of the wild west of machine building. It's pretty exciting things and technologies being designed right now for the 3D printer market. But plastic sliding parts again work really well in those applications. Lightweight, corrosion resistant. They're quieter to some extent, and they also are plastic. And I know a lot of 3D enthusiasts like to keep things plastic. In fact, igus is releasing a printable material that 3D printer enthusiasts are able to use to, it's a tribological plastic, so you're able to design your own plastic bearings using our filament, which is just now being released. Aside from linear parts, also 3D printers use a lot of plastic bushings for pivoting or rotary applications, as well as plastic lead screws and nuts, also designed by igus. One absolutely core industry for plastic composite bearings is packaging, the packaging machinery business. A lot of applications. One of the classic ones would be the welding jaws on vertical form fill seal machines. These are basically machines that have a hopper above that might dispense chips into a bag, and these welding bars or welding jaws are the parts that close, usually with the heat through heat. Again, really nasty environments, depending on what the end user is packaging. Could be harsh. Things like onions, or it could be chips, could be mulch, could be all sorts of different media. Plastic bearings, again, due to their lack of wet lubricant, really thrive in these applications. Another benefit is that ball bearings, because of their reduced ability to handle accelerations, the action profile of the application for this one particular customer had to be slowed. But because plastic parts don't have problems with acceleration, because there's no moving parts, a customer was able to increase the throughput on their machines by 20%. So they're able to market a machine with 20% higher throughput due to the fact that the acceleration could be increased without damaging the shaft by the use of plastic sliding parts. And again, an upfront cost savings. You don't have to buy heavy cane shafting and expensive stainless steel finished, as well as plastic ball bearings. This is actually one of my favorite videos. It shows igus DryLin T, which is dimensionally interchangeable with a lot of profile style guides, at work on a welding gun in an automotive application. DryLin was used because of the plastic inserts were able to basically push the weld splatter out of the system without damaging the plastic parts. Ball bearings used in this application, right when the weld splatter would hit the rail, could embed themselves into the ball bearings, causing damage to both the ball bearings and the rail itself. So another application where DryLin was successfully able to replace ball bearings environmental problems. Probably not so much for this type of robot, but for a lot of robotics where the robot's not quite so large, another ideal benefit of a plastic part with an aluminum rail would be the weight reduction as well. Here's another really cool robotic application that's using a round plastic insert. These are flex picking robots, pick and place. Ideally, the benefit of the plastic part is, number one, the idea that there's no lubricant, again, to get on any of the parts that you're picking, but also the fact that the parts are lightweight creates less stress in the other components on the system and enables the inertia to be reduced and the overall application to run a lot smoother than it could had it used heavier parts.
Here's an overall comprehensive look at the DryLin product family by igus. So this is our linear bearing specialty line. Starting from the top left, you'll notice a series of round parts. Those are interchangeable with recirculating ball bearings. We also offer aluminum shafting, steel shafting, and stainless shafting, both inch and metric sized. Below that, you'll see DryLin T, which is interchangeable with common profile rails that are on the market, but again uses plastic sliding parts instead of ball bearings. In the top center, a product line we've discussed a little bit earlier is our DryLin W Toolkit, which is a cool and unique flexible offering by igus to offer kind of unique solutions as far as different geometries and materials for engineers, and kind of setting a new standard for a linear bearing product group. Below that, you'll see a belt drive with a motor. That's just a reminder that igus can also provide fully actuated solutions with either tooth belt gears, lead screw drives, or gear racks with stepper motors or DC motors, as well as cables. And on the top right is DryLin N, which is a series of low-cost, low-profile linear slides. And on the bottom right is DryLin SD. That's our screw drive technology, which is available in Acme, trapezoidal, featuring zero backlash and anti-backlash functions, as well as dry spin, which is our own proprietary high helix lead screw geometry.
The core philosophy of igus is to design motion plastics, so really to push the envelope and develop new tribological composite materials that are strictly for motion applications. We try to offer a technical advantage to existing technology, a cost reduction to existing technology, and we also want to make sure that our parts are readily available and stocked for quick shipment. So we have facilities in Cologne, Germany, where we have over 400 injection molding machines, and also where we do over 5,000 tests on hundreds of materials each year to design and continue the advancement of motion plastics. The North American manufacturing facility is in Providence, Rhode Island. We have over 70 outside salespeople covering 2 different product lines from our bearing product lines, as well as cable carriers and high flex cables. I really urge you, if you have a problem with the bearing application in your facility or have any questions or any issues related to bearings, that you give us a call. We'll be glad to make an on-site consultation or help you over the phone. Maybe can help you with an igus solution as well. As well as facilities in North America and Germany, we also have subsidiaries in 35 countries worldwide. Again, all of our salespeople are factory-trained direct salespeople and are willing to, and more than willing to, make on-site consultations to help you with your bearing designs. All right, in wrapping up, I'd like to thank you again for attending the webinar. I hope you found it informational and not too dry, at least somewhat educational and entertaining. If you want to contact igus, again, please contact us on any of the methods on the screen here. And at this point, we're going to open the floor for questioning. I think we have quite a few already, so let's go to that.
Okay, I have with me today to help answer some questions, and there's been quite a few. I have with me Kristen Kroll from our technical sales department. And also, if anybody else has any last-minute questions, you can also feel free to use the chat feature. The first question is, what is the friction of the parts? It really depends on the specific material and the specific shaft or rail counterface material, but I would say on average it ranges between approximately 0.16 and 0.21 for dynamic friction.
Hi, this is Kristen. I have another question here. The question is, do you have FDA compliant materials? Yes, we have multiple FDA compliant materials. igus material A180 is the standard linear material due to its low wear properties as well as low moisture absorption and coefficient of friction?
And another one here, what is the series of, what grade of aluminum shafting do you recommend? The type of shafting we use for our round parts is 6061, which is a centerless grindable material. It's all precision ground. For our extrusions, we use 6063, which is easier to extrude material. If they come from another plant, actually we use 6060. They're all somewhat similar, but yeah. Kristen, you want to take the next one?
Yeah, the next question here is, do these bearings work well in a high cardboard dust environment? Yes, absolutely. DryLin linear bearings actually act as a wiper, pushing away dirt and debris, and because they require no wet lubricants, will not attract that dirt and dust.
All right, there's one here. What are the best elements for laser engraving, XY frame application? Probably the series that we would tend to lean towards for any XY applications would be our DryLin W, possibly with some adjustable carriages. That's definitely a question. If we're able to contact that questioner offline too and get more specifics, it would be helpful.
Another question here is, what is the low temperature range? Is it minus 40 by chance? Yes, actually we can go actually a little bit lower than minus 40 with some of our specialty materials. With iGlide T500, the negative temperature is actually minus 148 degrees Fahrenheit. Good question, thank you.
Another one here, does igus provide all types of shafting? Yes, we have all types, not only the aluminum, but for applications where you need to use steel for flex purposes, we have steel as well as stainless chrome plated.
Another question here, somebody needs a bearing with custom geometry to fit into an existing design. Does igus manufacture customs? Yes, absolutely. For high volume, we can look at tooling, and for lower volume, we have bar stock and plate materials available from stock. So we usually ship those materials within 24 to 48 hours.
Does your application calculator factor in dirt or dust? The lab test itself were not done in dirty or dusty environments. However, on the first page of the application calculator that we call our expert system, you're able to click a box that basically says if dirt and dust is present, and it will remove some of the systems that are basically shaped like a trough. So yes and no, I guess, is the simple way to answer that question. But we do have a lot of experience with dirty environments, so I would say it's probably a good application for us.
Another question here, do you offer CAD files for your standard linear bearings and rails? Yes, we offer multiple types of files from our homepage. Go to www.igus.com, put your mouse on the Tools and Resources button, and then you can click on the bearing CAD files.
Okay, next question here is, can the 2-to-1 rule be overcome by just oversizing the motor? It cannot. Actually, the 2-to-1 rule is based on friction, purely friction, and you can't oversize the motor, because basically if the harder you try to drive outside of 2-to-1, the more force it actually requires to overcome the 2-to-1 rule because of the coefficient. So it's kind of a catch-22 in that instance.
Another question here, does igus offer linear bearings with clearance adjustment? Yes, absolutely. DryLin, we have DryLin T with manual and automatic adjustment, DryLin W with a manual adjustment, and DryLin R, which is our round shafting line with an adjustable feature as well.
Next question is, can your systems be used with motors? Yes, we offer motors. We offer stepper motors as well as DC motors.
Yeah. Another question here, when choosing a DryLin linear system, where is the best place to start? Well, from our website, you can access, if you scroll down to the center of the page, you can click on the picture of the DryLin W rail system. From there, you can access our DryLin 2.0, which is our DryLin linear product selector configurator. Or you can call 888-803-1895 and ask for bearing inside sales. We'd be happy to help.
Another question is, are there retrofit kits or inserts available to replace failed ball bearing assemblies that are mounted in standard linear bearing blocks? That's a great question. Our DryLin R series, we do sell the adapters as well as liners that can replace those ball bearings. It is really critical that we look at the application just to make sure that we're not going to run into any problems with either clearance, since you've been using ball bearings, or with the 2-to-1 rule. So yes, absolutely, we do have those.
Another question here was what is the highest temperature that our bearings can handle? Our T500, which is our high temperature material, which also has really good chemical resistance, can handle long-term temperatures of 482 F, short-term temperatures of 599 F. With this material, though, we would recommend running on hard or soft stainless.
Okay, another question here. Good question. What happens if the parts do get lubricated? It's generally not a problem to lubricate our parts. In fact, a lot of people who own agricultural equipment or lawn care equipment may lubricate our parts even though they don't require it. They won't hurt necessarily. We do have a list of usually petroleum-based greases or oils are fine for our parts. But all of our lab data in the catalog is based on dry running applications.
Another question here is, does igus offer plain bearing nuts threaded with Acme thread? Yes, we have a standard line of lead screw nuts threaded with an Acme thread. You can see our offerings if you go to our home page and click on the lead screw and nut icon. And there's also a configurator there where you can run your application.
All right, another one is, can I use existing linear shafting or profile systems with DryLin bearings? You can use linear shafting if it's the standard ball bearing type round shafting. But as far as profile rails, we do have parts that are interchangeable as far as the hole pattern goes, but you can't, in general, take one linear bearing off of one profile rail and put it on somebody else's profile rail. They're all proprietary in that regard.
And another question here is that, do you offer low-profile systems and mini systems? We actually offer 2 low-profile and small footprint type systems, which is our Mini T and our DryLin N. Good question.
Another one is, do you offer parts that are press fit, replacements for brass bearings? Yes, we do. We offer a full line of not only linear sleeve bearings, but also, linear bearings, but also sleeve bearings that are easily press fit into housings that match a lot of the industry standard housing sizes.
Another question here is, what kind of precision can I expect from a plastic plain bearing? Typically the running clearance is a couple thousandths. With our DryLin Expert system, you can actually calculate the free play at the center of gravity of your application, and our inside sales or outside sales staff can help run that application. We also have adjustable bearing options where you can adjust out some of that clearance, increasing the precision.
Okay, another question is, someone has an application with a 3D printer. Do we have an estimate of the bearing cost for a system built with a 3 steel rail? It's best to contact us directly for that. We do a lot of work with 3D printers. I know a lot of 8mm round shafts use our parts. We can definitely contact you offline about that specific question. And here's another one. Can linear steel or titanium shaft be combined with igus linear bearings? Linear steel, absolutely. In fact, our iGlide J material and our recent material we just developed called E7 get extremely excellent wear results. In fact, the E7 material, which is brand new, gets up to 8 times better resistance than some of our older materials. So absolutely. As far as titanium shaft, I'd actually have to check on that. So we'd be glad to follow up with that question online as well. And okay, very last question.
There's another question here. Does T500 material have a thermal resistance value? We have in the thermal conductivity and the coefficient of thermal expansion for T500 listed in our catalog, and we'll get you that information.
Okay, and I think that's about all the time we have left in this webinar. I really want to thank everyone for their time and their excellent questions at the end. And don't forget to please contact us if there's further, if you ever have any problems with bearings of any type. We're always glad to take a look and send someone in or help you over the phone. Thanks again.